Okay, so in today's class, we're going to look at the use of trigonometry in bearings. What's important for us with this class is that we can move angles around in bearing diagrams and make right angle triangle questions. So our first question here is Therese sails her boat from point A for a distance of 6 kilometers. So she starts off here and she sails across like that. She does this on a bearing of 130 to arrive at point B. She then sails from point B for a distance of 7 kilometers on a bearing of 046 till she arrives at point C. To arrive at point C. There's Therese's journey shown in the diagram. So our first thing we need to do is we need to find the angle ABC. So ABC is this entire angle shown here. We need to find this angle. The main thing to work with bearings is, so a bearing is given as a rotation from north. It's given as 3 digits, 130 or 046 or 270, whatever. It's a rotation anti-clockwise from north. So here in the diagram we show north. So a rotation of 130 will bring us round to here, and then we start heading out on a vector in this direction. This is the bearing 130. Now what's useful with bearings is north is always the same. North is always in the same direction. So to help you with this diagram, if we draw a straight line here, this is the line pointing towards north, then we do another one here. These two lines are parallel. These are parallel lines. So what makes this difficult is, to begin with, we need to find the size of this angle here. How can we do that? How can we find the size of this angle in green that I've shaded? So Tiana suggested to us that this angle that we're after, I'll call it alpha. She suggests that alpha is equal to 180 minus 130. She's correct. Why? Why is this true? Does anyone remember? Something like the Z thing. It's the Z thing is an alternating angle.
The angle from underneath the first line is like the same as the one from above, like the point.
Yes, you know, the theory has a much shorter name than that. What is the theory that we're using? Ooh, we're getting there, Come on, spark it, it's coming up in the brain. Co-something or other. It is starting with co. Sorry? Coordinate angles? No. Complementary angles? No. We're getting there. Can you put your words together? These are co-interior angles. It came. These are co-interior angles, and the sum of co-interior angles is 180 degrees. But Ella mentioned the Z thing as well, because that one's also very useful. That would let us flip this angle down to here is obviously going to be 130 as well. That's part of the Z thing. This angle here is also going to be alpha. That's part of the Z thing. These are alternate angles. So all of those triangle traversal theorems about alternate angles, I heard someone mention corresponding angles. So if we were to continue that line there, this one would be alpha, because these ones are vertically opposite angles. And if we were to continue this line here, this one would be alpha because these are corresponding angles. So all of that type of stuff helps. The most important one is the co-interior angles and the alternate angles, the Z, and it lets you move them around. But in order to use those, extend your north lines into parallel lines. Notice I go all the way through like that. And once you see that diagram, it starts kicking in. Arsham, enough now. Can we take the earbud out of your ear? Stop texting on your phone and try and pay attention. Okay, so draw on your diagram to help you. If you're struggling to see it, extend those lines all the way through the north arrow to set up some parallel lines. And then you start to see the diagram easier. Because when you worked with us in grade 9, they looked a lot more like this. And that's the information that we're using. All right, so we can flip that angle. We can say that alpha there, if we come up with our answer now, the angle I've marked alpha is 180 minus 130, which will be equal to, can anyone do that math? Raja? Let's try and pay attention. 50. So angle ABC is going to be 50 plus 46, 96 degrees. Okay, so that gets us this whole angle here now as 96. B, calculate the distance from point A to point C. So lastly, we need to go from point A to point C like this. Don't move it up there, I want it here. Nope, it really wants it to be there. All right, so let's pull that off into a triangle. Sketch it as a triangle instead. This is A, C, B. Where after X, we've got 6. We've got 96. Oops. We've got 96. And we've got 7. Which formula can we use now for B? Cosine rule. Why do we think cosine rule? We don't have an opposing angle. We don't have a known side and opposing angle. Arsha? Problems involved where you don't have a known side and opposing angle use the cosine rule. Cosine rule usually has 3 sides in it, in the problem. One of them is unknown in this case, doesn't have to be unknown. Could be an unknown angle and just 3 sides, but this is a cosine rule. So we can set up our formula for the cosine rule, which is going to be x squared is equal to 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of 96 degrees. What does that give us for x? What does that give us for x? Let me just check that. I want to do that on the calculator. That's my calculator. Here it is. So I'm going to go for square root and 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of 96. Adia, what did you get? 9.68. 9.68. What's the units? Kilometers. Okay. So have a go now at this problem-solving question here. Start by trying to draw your diagram. Once you've drawn your diagram, try and solve the problem. It's a little bit trickier here, this one. Give you 5 to 10 minutes for this one. Okay, let's have a look at how we solve this problem. So we need to start off by making our diagram. So the hiker leaves the camps. Let's start off with our little set of these here. Our first line is going to be going up here like this at this kind of an angle because we're leaving it a bearing of 0.62. So this angle here, 0.62. Then at this point, we are going to be leaving here at 113. So we're going somewhere over here, it's like this. This is 7. This is 10. This angle here is 113. And then lastly, we need to return home and find this length here, x. So in order to solve this problem, we have to find this angle here. We have to find this angle here. This angle here is made of 2 pieces. We need to find this bit, and we need to find the yellow bit. Now the yellow bit is going to be supplementary with that bit there, isn't it? That bit, the yellow bit, is going to be supplementary with the 113, which means it's going to be 67. Because 113, sorry, this angle here is going to be 180 minus 113, which gives us 67. Now the green one is going to be an alternate angle with this one here. If I just zoom out a little bit and add my parallel lines, let me do it thicker. Add the parallel lines, you can maybe see it. Ella mentioned the Z earlier, and we see the Z here. We see the Z there. It means these are alternate angles. So this angle here is going to be the same as that one over there, which is 62. What's the sum of 62 and 67? 129 degrees, the full angle. So now we have enough of a triangle in order to use the cosine rule and solve the problem. X squared is going to be 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 129 degrees. What did we get here for our answer? Kai? Not 20 something? Lucas, what did you get? 15? 15.6. Okay, we got a challenge here. Let's have a look. $15.4. 15.4. What was the units of this one? Kilometers. All right, let's have a look at our next problem. So have a go at this problem. We should only take 5 minutes now for this one. Sorry, did I not show the... We just pause. All right, let's have a look. So with this problem, what I would recommend is, typically when I do this problem, I sketch it and I get the sketch slightly wrong. And then in order to solve the problem, sketch it again accurately. So I solved this problem, I sketched it twice. I'm going to try and get it right first time. But I didn't earlier, I got it wrong. So we are going to start off down here with our starting point. We leave this on a bearing of 315 until we get to here. And then we've got We leave this one on a bearing of 45. For a shorter distance, we come to about here. And then there's our last one. We then have to return home. And we have to find the angle there at that point. So our first one up is here. We have a rotation around here like this. Oh. This rotation is 315. How large is this angle here? How large is this angle here? Well, the points of the compass, this one is at 0, this one is at 90, this is at 180, this one is at 270. So the difference between 315 minus 270 is 45 degrees. So this angle here is 45 degrees. Now, I mentioned earlier it's useful to extend these as parallel lines like this. So I'll just pop this in for a minute so we can see it. We want to move that 45 degree up to the angle up there at the top. How can we do it? Well, let's have a little look. So here we've got, if this one is 45 degrees, then if that one is 45 degrees, then this one is also 45 degrees, which means that this one here is also 45 degrees. We can see this as alternate angles. Where are my alternate angles? I'm not getting it. I'm not getting it. Yes. So for this one, why don't I draw my parallel lines going in this direction? Here. And this one here is going to be 45 degrees there. And my alternate angles are going to be there like that. And there we see them. You see the alternate angles. So let me pop this one in. We've got 45 degrees here. Next up, we're told that this is a bearing of 045 there. So that one's pretty easy to see that this one is 45 degrees here. So that means that this angle here is a right angle. We got a right angle there at the top. That one's going to be 90 degrees. We're given some lengths. We're told that this one is 8, this one is 6. So we can start off by finding the angle in the triangle. We want the angle in the triangle, which is this angle here. Let's pull that triangle off into another diagram. And I'll just draw it like this. This one is 6, this one is 8, and we want the angle theta here. How can we find theta? How do we find angles in a right angle triangle? SOHCAHTOA. SOHCAHTOA. So Skander says that we can use inverse tan. He's correct. What he means on this one is we're going to use SOHCAHTOA. So there's TOA. It tells us that the tangent of the angle is equal to the opposite over the adjacent. So theta, he said inverse tan. So tan inverse of 8 over 6 will give us 53.1 degrees. So now we've got this angle here as 53.1. In order to get the bearing our bearing that we're after is this angle here. This angle here. That's what we're after. In order to find that, we must find this angle there. Well, if we know that that's 53, we just got to remove the other bit. Now we can again use our parallel lines. We've got one there, we've got one there. The angle that we're trying to remove is this one here. That one is alternate to this one here. There's another Z. So the one that we're after is going to be 45 because this is also 45. So we can say that this angle here is 45 degrees. So if this one is 45 degrees and that one's 53.1, then this angle here that we're after, alpha I'll call it, is 53.1 minus 45, 8.1. So our bearing here, which is this angle there, is going to be 180 minus 8.1, which is 172, or 172. So I'll just answer the question finally. There's all our diagrams, all our working. He travels at a bearing of 172. That's our final answer. Okay, tricky that one. Okay, that is it for today.